What is USB HID? What does it stand for? What does it mean? What can we use it for? Let's dive into it. USB stands for Universal Serial Bus, and it's a standard that is used for cables, that is used for connectors, but it's also a protocol standard. Now it's important to understand here that USB is not just one, but all of those things. USB describes all of those things working together. To make this more clear, I have an example. This is a very modern USB cable and I just took a screenshot of it from Amazon. So you can see this is obviously a cable, but it's a cable that comes with a certain connector. In this case, a USB Type-C connector, right? It's a USB connector. And this cable is made for USB version 4. This is the protocol or the standard version. So we can expect that this is capable of everything USB version 4 is capable of. This is why we see other stuff mentioned in the title, like driving 2 4K displays at 60 Hz and all that stuff. But really, what they're trying to tell you here is this cable is made for USB version 4. This is also why we have a USB Type-C connector, and this is also why the cable itself is manufactured in a way that supports the speeds and requirements USB version 4 comes with, right? So this is really an all-in-one package. That's the point I'm trying to make here. So what kind of USB connectors do we have here? There's this great table you can find on the Wikipedia page about USB. And in the top, you actually see the different versions of USB. So it started back in 1996 with USB 1.0. This is how old this standard is. Kind of crazy, you think about it. And it goes way up to 2019, not that long ago, when they released USB 4. And you see a bunch of connectors listed below. Let's go through them. So it all started with USB Type A. This is the classic connector, you know it. This is probably what we all think of when we talk about USB. The classic, right? There's also USB-B. This is typically used for, or at least I typically use it for stuff like printers, or my microphone has it. Some old Arduino boards have it, like the classic Arduino Uno. But yeah, not that common anymore because it's a really big connector. There's mini USB, which is much smaller, but it got replaced by micro USB at some point, which was super common with all smartphones out there, and a lot of Arduino boards and Raspberry Pis and stuff like that still use that connector. It's very common. And then we have USB 3.0. Now with USB 3, it's getting a bit confusing because there is USB-A 3.0, there is USB-B 3.0, and there's also micro USB 3.0. Two of them you see in the picture on the right. You see USB-A 3.0, which is typically blue instead of white or black. And the micro USB 3.0 is actually bigger because with USB 3.0, they added pins to the connector. They added pins to be able to transfer data more quickly, right? To increase the speed of the protocol. That's why they needed more pins, and that's why they added them to the connector, making the connector bigger. But now we have this huge mess of cables. And this is not really user-friendly. This is all rather confusing. But luckily, we are all moving towards USB Type-C. This is replacing all the other connectors, and this is great because USB Type-C is reversible. You can't plug it in the wrong way. It works both ways. You just need USB Type-C to Type-C cables. You don't need, Type A to Type B cables or stuff like that anymore. It's just one cable you need. And yeah, everything is moving towards it. And it's not me that's saying this. It's actually in the standard. USB 3.2 and up is USB Type-C only. Now there's one confusing thing in this picture that I need to address, and that it looks like USB Type-C came out with USB 2.0 in 2001, which it didn't. USB Type-C really became popular in like 2015, 2016, so it's not that old yet. but it is made to be compatible with USB 2.0 because there are USB 2.0 devices out there that will continue to use USB 2.0 simply because they don't need the higher bandwidth that USB 3 and up uses. You can imagine a keyboard or a mouse, they don't need high throughput, they don't need high speeds. They just need to transfer the data accurately and that's it. Keyboards don't need to be faster. There's no need for that. So USB Type-C is made to be backwards compatible, so to really replace those other connectors. But it is a relatively new connector, and we see it replacing everything. So what kind of USB devices do we have? This is a list of common devices I use on a daily basis, but of course there are way more. But let's just go through it. We have flash drives, like the typical USB flash drives. You could also have external HDDs or SSDs, but they are all some form of memory device. We also have adapters. I have a lot of USB-C dongles lying here or USB hubs. So yeah, that's very common as well. Computers, this is interesting because, for example, you could connect a flash drive to your phone and access the flash drive contents from your phone. But you can also connect your phone to your laptop, and now the phone becomes the flash drive because now you can access the phone's files from the computer, from the laptop. Pretty crazy. So yeah, obviously computers use USB, and they can both sometimes act as USB host and sometimes as USB devices. And we charge computers now through USB-C. Like we can run entire laptops, just power them completely over USB, thanks to a technology called USB power delivery. Pretty cool. So yeah, this USB is becoming more and more important to our technology life we have built here. We also have audio equipment, microphones. The one I'm talking into right now is connected through USB. Speakers, headphone adapters are also a thing because not every device has a headphone jack anymore. And keyboards, keyboards or mouse or game controllers are also a type of USB devices. Now, why am I listing all these things? There's one question that arises here, and that is, how is this all possible? How are all these devices connected through USB? Now, obviously, they all have a USB connector, right? But those are fundamentally different devices. A flash drive has nothing in common with a microphone or a keyboard. Those are completely different devices. They work completely different. They are used for different things. How is it still possible that we use the same connector and the same standard to use those devices? And a big part of the answer is USB device classes. So again, this is a table I took from Wikipedia because it has a really good overview of the classes available. And basically what we have is a list of device classes available. So any USB device falls into one of those categories. And these categories define how the computer talks to the USB device. Right? If the device says, "Hi, I'm a USB hub," the computer will then know, you're a USB hub. Okay, then I need to apply a certain set of rules to talk to you. It will then know how to use that device. And obviously, this is one of the main features of USB, that we can use all these different devices through one connector, through one standard, through one cable. That's amazing. But we are going to have a closer look at one of those categories, the Human Interface Device, or HID for short. So what are human interface devices? Basically, we humans need to talk to the computer. How do we do that? We need to give the computer commands, we need to interact with it, so the computer can do something for us. But how do we do that? It can't read our mind. We need to give it commands. And how do we do this? Through an interface. This interface could be a keyboard, could be a mouse. It could technically also be other things like voice control. But since we are talking about USB HIDs, we typically talk about keyboard, mouse, or game controllers, joysticks, any kind of stuff in that category. But what they all have in common is that you have some sort of button or joystick or mouse wheel that you move as a human. You can use it physically, and then the computer interprets that to do something. So typically keyboard, mouse, or game controllers fall into the USB HID class. And what makes this so special is the ease of use. It is so easy to use HIDs. You just plug them in, you don't need drivers, they are backwards compatible. You can plug in a 20-year-old keyboard into a brand new computer, it will work. You can plug in a brand new keyboard into a 20-year-old computer, it will also work. They are backwards compatible, just plug them in and start typing. There's no hassle. And that's great. And that's actually necessary if you think about it. Because if we had to install a driver to use our keyboard before we can use the keyboard, then how would we install the driver without a keyboard? How would that work? We wouldn't be able to use the computer in that case. Maybe with the mouse, right? But what if the mouse has the same problem? So really, this is great, but it's also a necessity. We need interface devices to just work plug and play to be able to use the computer. And they work everywhere. It doesn't matter what operating system you use. It doesn't matter if you are interacting with a server or a phone. Almost every USB host device is capable of supporting USB HIDs. Part of the reason why that is because they are such a well-defined device class in the standard. But the point I'm trying to make here is they are super easy to use and they work almost everywhere. So to summarize, USB stands for Universal Serial Bus, and it's a standard used for cables, connectors, but it's also a protocol. USB device classes are used to identify and enable support for such a variety of different devices. One of those classes is called HID, or Human Interface Device. And these devices are used to control the computer. Typically, they are keyboards, mice, or game controllers. And they work plug and play. Keyboards and mouse don't require extra drivers. They work with almost every computer out there.